Hi everybody, we are starting chapter 2 today. Please make sure that as you start your notes today that you're titling it exactly the way that you see it here, section 2.1, use of properties of exponents. I need to see the title so that when I am looking at your notes, I can know how to give you credit for which sections. Posting pictures of your homework is not credit for notes for that section. Okay, so this is just a reminder. Remember back when we were learning that repeated multiplication is really the use of exponents. So 2 to the 1, 2, 3, 4, 5 times itself is really like saying 2 to the 5th. Also, if we have this expression 2 to the 3rd times 2 to the 5th, I could say that's like saying 2 to the 3rd is like 2 times 2 times 2 times 2 to the 5th is like saying 2 times 2 times 2 times 2 times 2. So if I were to multiply these all together, that's 2 times itself 8 times. So we know that's 2 to the 8th. So we know what happened is basically those exponents ended up adding together to get 8. Okay, so just keep that in your brain as we move ahead. Now we're going to talk about properties of exponents, and this is also on page 88, which is in your ebook, page 178. Okay, so make sure that you put in, you're going to make your chart, property name on top, definitions, and here's an example of them as well. So first things first, here's our product of powers property, and that says, I don't know why this is still here, but anyway, it says that if we have some number to the m power and the same number to a different power, we can write that as the base, and we're going to add the exponents. Okay, kind of like the example that we just talked about. So 5 to the 3rd times 5 to the negative 1 is like saying the same base of 5, and we're going to add the exponents of 3 and negative 1, which is 5 to the 2 power. And as long as you can simplify these down to one expression of an exponent, that's totally fine. All right, the next one is it's called power of a power. And I just took out. So we've got power of a power. So here we go. Power of a power. Here's what that means. If I've got a number to a power and I raise it to another power, that means I can do this. I can take the base A number, and instead of raising a power to a power for their exponents, we're going to multiply them. So for example, if I had 3 to the 3rd and then squared it, so a power to another power, this would be like saying 3 to the 3 times 2 in the exponent, which is 3 to the 6. All right, let's talk about power of a product. So when we're talking about power of a product, here's what we mean. We've got two numbers multiplied together, which is a product, and we're raising them to a power. What that really means is we're distributing that power to both parts of the product. So I can rewrite this as A to the M separately from B to the M. So for example, if I had 2 times 3 to the 4th power, instead of multiplying 2 times 3 is 6 to the 4th, we would write 2 to the 4th times 3 to the 4th, and you could simplify that as well. All right, let's talk about the negative exponent property. So just like it says, if I've got a negative exponent, that means if I've got some number to a negative exponent, keep in mind a negative exponent does not mean that the value is negative. Okay? It does mean that it's a fraction. Or you can say reciprocal. Okay, so this negative on the m really looks like this. So this negative on the m turns into a 1 over, and then the leftover of a to the m goes on the bottom. So I call this 1 over the leftover. Okay, or you could think of this as a negative exponent turns into a reciprocal of the value. Okay, so for example, if I had 7 to the negative 2, that negative x on the exponent becomes a 1 over or reciprocal, and on the bottom goes 7 squared. So if I were to simplify that, 1 over 7 squared is really 49. All right, let's talk about zero exponent property. So a zero exponent is literally exactly what it sounds like. I've got some value for a to the 0 power, and anything to the 0 power is 1. As long as a does not equal 0. So anything to the 0 power is 1 as long as it's not 0 to the 0 power. So for example, if you had negative 2 to the 0 power, it's 1. If you had x to the 0 power, it's 1. If you had a happy face to the 0 power is 1. Mrs. Salzarulo to the 0 power is 1. Okay, so anything to the 0 power is 1. Keep in mind, it is not multiplying by 0. Okay, let's talk about our quotient of powers. So here we go. Quotient of powers means this. I've got a quotient, and each part of the quotient is raised to, whoops, sorry, this is an A, to a different power. If I have the same base in both parts of the quotient, A and A, I'm going to keep the A, and instead of dividing, I'm going to subtract the exponents. So it always goes subtract the top minus the bottom exponent. Okay, so for example, what if you had 6 to the negative third all over 6 to the negative 6? Well, the base is the same. We can see that right here, 6 and 6 is the base, so 6 stays, and then we go the top number minus the bottom exponent, which in this case, I'm going to zoom in here a little bit. We're going to add the opposite, and we get 6 to the negative 3 plus 6 is really 3. And you could simplify that to a number, but that's okay. You can just leave it in terms of one exponent. Okay, and let's talk about power of a quotient. So just like it sounds, we have to have a quotient, which is two numbers being divided by each other, and it's all raised to a power. So kind of like our power of a product, we're going to distribute that m to both of those terms in the top and the bottom of the quotient. So we end up with a to the m over b to the m. So for example, if you had 4 over 7 squared, instead of putting 4 over 7 and then squaring it, which is a crazy decimal, we're going to say, okay, this is really equal to 4 squared over 7 squared, which is 16 over 49. And that's it for our chart. Make sure you have this chart in front of you as you do your homework. Again, if you need to take a screenshot, you can. If you need to look at it in your book and take a screenshot or take a picture of that, that's fine as well. It's the same chart. All right, let's go ahead and practice some evaluating. If I'm going to evaluate this, remember I've got this is a product to a power. So I'm going to use my property of product of powers, or excuse me, a power of a product, and we're going to distribute that power to each part of the product. So we've got negative 4 squared times 2 to the 5th squared. Now this will simplify down, so this is called the power of a product. And then in your homework, you're going to be asked which property you used. So now we can simplify this. This is 16, but this, I'm going to use the power of a power property, And I know 2 to the 5 to the 2 is really like saying 2 to the 5 times 2, which is 16 times 2 to the 10. And that becomes, if I multiply that out, 16,384. Okay, we're going to simplify that. So if you have to use more than one property, list both. All right, let's do this next one. I can see 11 to the 5th over 11 to the 8th, all to the -1 power. So you have two choices here. We can either put 1 over the leftover and have to divide by a fraction. But remember that -1 exponent, where we have a negative exponent, it can mean 1 over the leftover, or it can mean the reciprocal to make it a positive exponent. So if I want to write this -1 instead of a negative, I can make it to the +1 if I flip what's inside the parentheses. And now I can simplify that. And this is the quotient of powers property. Okay, so we have two properties, negative exponent property and quotient of powers property. And we know, okay, if these are the same base, which these are, 11, top minus bottom, because anything to the 1 power is itself, so this is it's invisible, it kind of goes away. And we've got 11 to the 3rd. Okay, let's go over scientific notation. Remember, scientific notation is this form, some value of c, where c can be between 1 and 10, but not less than 1 and not 10 or more, times 10 to the nth degree or nth power, where n is an integer. Now remember, an integer can be a positive or negative whole number or 0. So remember, scientific notation always looks like this form right here. So if I wanted to put a million, which is right here, into scientific notation, first I have to know where is the decimal place for a million. Well, I know a million has a decimal place right here after the ones. So to turn this to scientific notation, I'm going to move this 1, 2, 3, 4, 5, 6 place value. So here's my new decimal. So now I put 1.0, which is significant digits, right? 1.0 times 10 to the 6, because I moved my decimal place over 6 times. This is in scientific notation because my C value is right here between 1 and 10, right? And it can equal 1. And then I've got it in the form of times 10 to the some sort of integer, which is 6. So let's do this one. A swarm of locusts can contain 85 million locusts per kilometer squared and cover an area of 1,200 kilometers squared. How many locusts are there in a swarm? So we know a couple of things. We know a swarm is what they're talking about here. We know that's 85 million per, which in math talk per means multiply, 1,200 kilometers squared. So first we're going to write this out. 85 million times 1,200 kilometers squared. So now we're going to put this in scientific notation just to help us not have to use such big numbers. So 85 million looks like this. But now we're going to put this into scientific notation to multiply it. So I'm going to know my decimals here, and I'm going to move it 1, 2, 3, 4, 5, 6, 7. This is really 8.5 times 10 to the 7th. Times, and I know my decimal place is here, we're going to go 1, 2, moving it over 3, so I get 1.2 times 10 to the 3rd. So I wrote this in scientific notation, and now we're going to multiply. So here is how to multiply two numbers in scientific notation. We're going to multiply just that C value or the two numbers. And then after that, we're going to multiply 10 with their exponents. So here we go. I know 8.5 times 1.2 times 10 to the 7th times 10 to the 3rd. Again, this is all just multiplication, so we can move things around. So 8.5 times 1.2, we get 10.2 times 10 to the, now this is just a product property of exponents, so we add the 7 and the 3, which is 10 to the 10. Now keep in mind, this is no longer in scientific notation because this number is bigger than 10. So we need to move that decimal over one more place, which is 1.02 times, and then to off, because we moved over the decimal one more place, this now becomes one more. This is 10 to the 11th power. So this is how many locusts there are, 1.02 times 10 to the 11th power. The part that you really need to know is how to do this, multiplying scientific notation. All right, let's go ahead and simplify this. Again, we're going to use our products. I see we've got b to the -4th times b to the 6th times b to the 7th. So we're going to use our product of powers and because they're all the same base, we could base b and then we can add the exponents. So this is b to the -4 plus 6 is 2 plus 7 is 9. Part B, we have a couple of things going on here. We have first, we have a negative exponent, but also we have a power of a quotient. So just before we deal with negative of the exponent, we're first going to deal with this one, power of a quotient. So I'm going to distribute that power to both the top and the bottom. So this is r to the -2 to the -3rd power over s to the 3rd to the -3rd power. And now this step right here means we're going to use power of a power. And we're going to say, okay, well, when I raise power to a power, I'm really multiplying them. So this is r to the -2 times -3 is 6. S to the 3 times -3 is s to the -9. And now we're going to use that negative exponent. Remember how I said a negative exponent can be 1 over the leftover, or we can say it's the reciprocal, which to get a negative exponent out, I can multiply it by the reciprocal of s to the 9, which is 1 over s to the 9, which would divide and make s to the +9 in the top. So another thing that we can learn, if a negative exponent is either in the numerator or denominator, to make it positive, so we're going to make it positive, a positive exponent, by moving it either up or down, whichever one it's not already. All right, our last one, we're going to take this apart because this is all basically multiplying. So we've got 16 times m to the 4th times n to the -5. And again, these are just being multiplied, so I can rearrange these however I need to. And I'm going to kind of split this apart. This is like saying 16 over 2 times m to the 4th times n to the -5 over n to the -5. And the reason why I did that is I wanted to group them by like terms just so I could simplify them a little easier. So I'm left with 16 over 2 is 8. M to the 4, there's nothing to simplify it with. And n to the 5 over n to the 5 is really just 1. Well, 8m to the 4th times 1 is just 8m to the 4th. And that's it for notes today. I'll see you back in class right now. Thanks.